Hello everyone and welcome back to the Intro Algebra video lecture. Today we are going to be starting the process of solving linear equations. So what this is going to involve is you actually solving equations and you actually solving for a specific variable. And this is going to be done in a variety of steps. We're going to start off with really simple what are called one-step linear equations, and then we're going to move into two-step and then more than two-step linear equations. So this is going to be a bit of a process that is going to take up at least the next few video lectures. So just to start us off with what a linear equation is. An equation in general is any mathematical statement that expresses that two expressions are equal. So an equation is basically a mathematical statement of equality. Therefore, an equation always has an equal sign. Now, there are many different types of equations that you are going to be learning in various algebra courses. You're going to learn how to solve a couple more of them in intermediate algebra, and then in college algebra, you'll be solving even more than that. In this course, we're going to focus on what are called linear equations. So a linear equation is an equation that has a variable whose exponent is 1. So that means the highest and only exponent in a linear equation is one whose exponent is 1. Now, a nonlinear equation is any equation that contains an exponent that's not 1, such as if you have an equation with an x squared or an x cubed in it, or any other exponent that is not 1, that is a nonlinear equation. I will say that in intermediate algebra and in college algebra and beyond, depending on how far you need to go, you're going to be solving a lot of nonlinear equations, and in this course, we're going to focus on solving linear equations. Now, a linear equation in one variable is any equation that can be written in the form of some number ax plus some number b equals some number c. Now, this is just the general setup of any linear equation. Notice there are no exponents. The only exponent that's hidden here is an exponent of 1, so that makes it a linear equation. And the equal sign makes this an actual equation. Now, A, B, and C here are just placeholders. A, B, and C can really be any numbers. The only exception is A, the number next to X, is not equal to 0, but B could absolutely equal 0, and C could also equal 0. So A, B, and C are just whatever numbers are in the equation, and the variable that you're trying to solve for, there's only going to be one variable at a time, at least right now. We are going to get into equations that have more than one variable. That is going to be a different section and a different video. But for now, in this video and the next few, we're going to be focusing on solving equations that have just one variable. But just keep in mind, there are equations that have more than one variable, and we're going to get to those later. Now, equivalent equations are two equations that have the same solution. So you're going to find that there are some equations that look very different, but you get the same answer for both of them, such as x equals 2. So those are what are called equivalent equations. Now, before we get into the process of solving linear equations, you do need to know how to check your answers. Because as you know, you have a limited submissions per question on my math lab, and on exams, you only get one shot at it. So you need to make sure that your answer is correct, especially if you're not totally sure about it. So there is a way to always be able to check your potential solution regardless of how simple or complicated the equation is. So a solution to an equation is any replacement for the variable that makes the equation true. So basically, the solution to that equation is whatever number you would be able to plug into the variable and make the equation true. Making the equation true would mean you get the exact same number on both sides of the equal sign after you substitute your solution and simplify. So to check to see if your solution is correct, all you have to do is substitute your answer in for the given variable. If the variable appears in more than one place, you're going to substitute that value into every single place that the variable appears. Please use parentheses when you are substituting a number in for a variable. Then what you're going to do is you're going to work with each side of the equation, and you're going to follow order of operations to simplify each side of the equation. And you're going to see if a true statement results. A true statement is when you get the same number on either side of the equal sign, such as 2 equals 2. This is a true statement. If you get a true statement, that means that your solution worked and that your answer is the actual real answer. However, if you get a false statement, such as 1 is equal to 0, which it doesn't, then a false statement like that would mean that whatever number you just plugged into the equation is not the solution to the equation, and you likely did something wrong. So we're going to be solving equations like this. 3x plus 1 equals 11 minus 2x. We're going to be solving more complicated equations like this in later videos, but we are going to be learning those in this chapter. So let's say that you have gone ahead and solved this equation and you get the answer x equals 2. And you want to see if x equals 2 is the actual solution. So you want to see if you did this problem right and if x equals 2 is the correct answer. So what we're going to do is we're going to take 2 and we're going to put parentheses around it, and we are going to substitute it into the equation into every single spot that we see the variable appear. So I see a variable right there, so I'm going to plug 2 in right there. And I see a variable over here, so I'm going to plug 2 in right here. Because remember, if you have more than one variable, if you have more than one of the same variable, you're going to substitute 2 into every single spot that the variable appears. Now, anything that is not an x needs to be left alone and left exactly where it is. In addition, this equal sign that's right here. Think of the equal sign as an immovable fence. You should never move the equal sign. In fact, you should be able to draw a mostly vertical line down all of your equal signs. Whether you're checking solutions or actually solving equations, you should be able to draw a mostly vertical line down all of your equal signs. Do not move the equal sign. The equal sign is a fence between the two sides of the equation, and it is really important that that fence does not move. So I'm going to keep the equal sign exactly where it is, and I'm going to substitute 2 with parentheses around it into each of these x's, and anything that is not an x needs to be left alone and needs to be left exactly where it is. So I'm going to leave this 3 alone. Then in place of x, I'm going to substitute 2, and then I'm going to leave that plus 1 alone. Then on the other side, I'm going to leave the 11 alone. I'm going to leave the minus 2 alone. And then in place of x, I'm going to substitute another 2 with parentheses around it. Now I'm going to work with each side one at a time. So I'm starting with the left side. Let's look at the operations that we have. We have multiplication and we have addition. So you might remember order of operations that was covered in the last video. What comes first, multiplication or addition? Multiplication comes before addition, so I'm going to do the 3 times 2 first, which is 6. Then on the other side, I have multiplication again, and I have subtraction. So once again, multiplication is going to come before subtraction. And remember that a number always takes the sign to its left. So this 2 right here is actually negative 2. So I'm going to do this multiplication next. I'm just going to leave that 11 alone. Negative 2 times positive 2 is negative 4. Then after multiplication, on the left-hand side, I'm going to do the addition. 6 plus 1 is 7. And then on the right, 11 minus 4 is 7. Now, we got the exact same number on each side of the equal sign. So yes, 7 does indeed equal 7. This is a true statement. So because we got a true statement, which is the same number on each side of the equal sign, that means x equals 2 is the solution. So in the case of checking your answer, that would mean that yes, I did this correctly. X equals 2 is the correct answer, so then you can circle it and move on. So I want you to try that for this next one. We are going to be solving equations like this that contain parentheses. So what I want you guys to do is, please use parentheses around this negative 1. I want you to use substitution like in the last video to check to see if x equals negative 1 is a solution to this equation. So go ahead and pause the video, try this one yourself, and then resume when you are done working. Okay, so when we check to see if let's say that you went ahead and solved this. So let's say you did the process that we're going to learn to solve this and you got x equals -1 as your answer, and you want to see if -1 is the correct answer. So what you're going to do is you're going to take your potential solution -1 with parentheses around it, and you're going to plug it back into the original equation into every single spot you see in x. So we're going to plug in -1 right there, and we're going to plug in -1 right there. Anything that is not an x needs to be left alone and left exactly where it is, especially the equal sign. So I have 2 times, in place of x, I'm going to substitute -1 minus 4. Do not move the equal sign. And then on the right, I'm going to leave the 6 alone. I'm going to leave the parentheses alone. In place of that x, I'm going to substitute -1 and then plus 2 and leave that alone. So what we're going to do is we're going to work with each side of the equation, and we're going to follow order of operations to simplify each side of the equation and see what happens. So on the left, we have multiplication and we have subtraction. Multiplication comes before subtraction, so I'm going to do the 2 times -1 first. So 2 times -1 is -2, and I'm going to leave the -4 alone for right now. Now you have a couple of different options on the right. You could distribute the 6 if you wanted to, or you could just do the operation that's in the parentheses. You can combine these two, so it really doesn't matter. You could distribute the 6 and then put them all together later, or you could just do what's in the parentheses, since these are like terms, and then multiply by the 6 later. It really doesn't matter. You're going to end up at the same answer regardless. Your work will just look different. I am going to do -1 plus 2 though, so -1 plus 2 is going to be +1. Then what I'm going to do is on the left here, I'm going to do that subtraction. Remember, you can turn subtraction into adding a negative. So -2 plus -4 is -6. And then on the right, 6 times 1 is 6. So each side of the equal sign has been fully simplified, and last I checked, -6 does not equal 6. So this is an example of a false statement. 6 does not equal -6. We did not get the exact same number on both sides of the equal sign. So because we did not get the same number on both sides of the equal sign, that means no, x equals -1 is not a solution. So if you had done this problem and gotten -1 as a solution, and this happens when you check it, that means you did something wrong with your solving. That means x equals 1 is not the correct answer, and you need to go back and check your work. Now, this process of plugging your solution back into the original equation to see if it works can be used for any equation, and it doesn't matter if it's a nonlinear equation. So this will work with the linear equations that we're going to do in this class, and this will work for the nonlinear equations that you're going to do in future courses. And just so that you could see an example of a nonlinear equation, here is an example of a nonlinear equation, and I'm going to show you what makes this nonlinear. This exponent of 2 right there is what makes this equation nonlinear. However, you're going to learn how to solve equations like this in future courses, but I'm just going to show you how this process of checking your answer, of substituting to check your answer, will work regardless of the type of equation. So let's say that you solve this and you get x equals -2 as a solution. We're going to see if x equals -2 is actually a solution. So I'm going to put parentheses around the -2, and like I said, parentheses are extremely important, especially when we have exponents. And we're going to plug -2 with its parentheses in for every single spot that we see in x. So we're going to plug it in right there in for that x, and we're going to plug it in right there for that x. Make sure that the exponent is outside of the parentheses. And then anything that is not an x needs to be left alone and left exactly where it is. And you should be able to draw a mostly vertical line down all of your equal signs. The equal sign should never move. So I'm going to leave this 2 alone. Then in place of x, I'm going to substitute -2 with parentheses around it. And then I'm going to leave the 5 alone. Leave the equal sign alone. Then in place of this x, I'm going to substitute -2 with parentheses around it. Leave the exponent alone, and then leave the -3 alone. Then you're going to work with each side independently, and you're going to simplify each side of the equal sign and see what happens. So on the left-hand side, we have multiplication and addition. So multiplication is going to come first. Positive 2 times negative 2 is negative 4. And then I'm going to leave the plus 5 alone. And then on the right, we have negative 2 squared minus 3. Well, exponents come long before subtraction, so I'm going to do the exponent first. And because the parentheses are there, that means the negative is also getting squared. So negative 2 times negative 2 is positive 4. And then I'm going to leave the minus 3 alone. Then, again, leaving the equal sign alone, I'm going to simplify each side. So negative 4 plus 5 is going to give us positive 1. And then 4 minus 3 is going to give us positive 1. So because we got the same number, the exact same number on each side of the equal sign, this is a true statement. Because this is a true statement, and yes, 1 does indeed equal 1, is x equals negative 2 a solution to this equation? Yes, x equals negative 2 is a solution. So you are not required to check your answer every single time, but as the equations get more complicated, and especially if you're ever not quite sure if you did it correctly, this method is a foolproof method of checking your answer. So if you're not sure about an equation that you just solved, especially if it's on an exam, as you notice, it doesn't take very long. Just plug your solution back into the original equation, the original one, before anything happened, before you did anything. So just plug your potential answer into the original equation and use order of operations to simplify and see if you get a true statement. If you do, that means you're great, you did it right and you can move on. But if you don't get a true statement, that means you did it incorrectly and you need to check your answer. And you need to check your work. So while you don't have to check your answer every single time, it is something that I highly advise you to do, especially if you're not feeling quite sure about it. Now, for the rest of this video and for the next couple videos, we're going to go over the process of how to get a variable by itself. So solving an equation means getting a statement like x equals negative 2. So what essentially solving an equation involves is you getting the variable by itself, which means on one side of the equation, you just have the variable, and on the other side of the equation, you have whatever number you get. So in order to get a variable by itself, you need to move everything else to the other side of the equal sign. So a variable is considered by itself when the only thing that is being multiplied by it is 1, and there is nothing being added or subtracted. That's what's considered a variable being by itself. If the only thing being multiplied is a positive 1 and there is nothing being added or subtracted. Now, to move everything else to the other side of the equal sign, you need to do the opposite operation than the one that is presented in the equation. So for example, if the equation has addition, the opposite of addition is subtraction. So you would use subtraction to cancel out that addition. Now, here's the thing. This is like the golden rule of algebra, and this is going to hold for any algebra course that you take. You need to keep the equation balanced, which means that whatever you do to one side, you must do the exact same thing to the other. And I cannot stress that enough. If you're going to add something to one side of the equation, you need to add the exact same thing to the other side. And that goes for anything that you do, whether it's adding, subtracting, multiplying, dividing, anything. Anything that you do to one side of the equation, you must do the exact same thing to the other. That's like the golden rule of algebra. So let's start off with some simple one-step linear equations. So as their name suggests, a one-step equation only requires one step to solve it. And we're going to solve one-step linear equations first by using addition or subtraction. And once again, the golden rule of algebra. Whatever you do to one side of an equal sign, you must do the exact same thing to the other. So if there is addition on your variable, So if there is something being added to your variable that you want to get rid of to get the variable by itself, then what you're going to do is you're going to subtract that value from both sides of the equation. If the equation involves subtraction, so if something is being subtracted from your variable, then what you're going to do is you're going to add that value to both sides of the equation. Remember, positives and negatives are opposites. So if there's a positive number, you get rid of it by subtracting. If there's a negative number, you get rid of it by adding. Now, in either case, what's going to happen is on the same side of the equal sign as your variable, you're going to have a pair of opposites. Opposites are always going to add up to 0. And you might remember from last video that adding 0 doesn't do anything. So x plus 0 is just x, and when you add 0 to anything, you just get itself. So that's it. So remember, if you want to check your answer, even if it's just a mental check of your solution, you don't have to write it down if you don't need to. But to check your solution, you can substitute your answer back into the original equation, see if you get a true statement on each side of the equal sign, and see that your solution satisfies the equation. So these are all examples of one-step linear equations. So for the first one, we have y plus 9 is equal to 17. Now, just like with checking your answer, when you solve an equation, you should be able to draw a mostly vertical line down all of your equal signs, which means your equal sign should never, ever, ever move, regardless of how much you're moving to the other side of the equal sign. Think of the equal sign as a fence. The only way to get a term from one side of the fence to the other is to do the opposite operation, and that fence is never going to move. So here is the variable that we're trying to get by itself. So let's look at the operations that are on this same side of the equal sign. So on this same left side of the equal sign, we are adding a 9. So this is adding a positive 9. So what's the opposite of adding a positive? The opposite of addition is subtraction. So what I'm going to do to undo this plus 9 is I am going to subtract 9. And then whatever you do to one side of an equation, you must do the exact same thing to the other. So that is what I mean by keep the equation balanced. Whatever you do to one side, you must do the exact same thing to the other. So then over here on the left, positive 9 minus 9. 9 minus 9 is 0. So what essentially happens is they cancel out. And yes, you can draw a line through it like this because opposites are always going to add up to 0. Now, y plus 0, remember adding 0 doesn't do anything, so y plus 0 is just y. Then don't move the equal sign. And then on the right-hand side, we're going to do the exact same thing. So 17 minus 9 is 8. So at this point, the variable is actually by itself because the only thing being multiplied by this y is a hidden positive 1, and there's nothing that's being added or subtracted. So this is now our final answer. Now, if you were to check your answer, you can even do this mentally. If you wanted to check your answer, all you would have to do is substitute 8 back in for y, and then simplify and see if you get the exact same number on both sides of the equation, which, since you do, that means y equals 8 is your final answer and is the correct answer. So just remember, you don't have to do this every single time, but if you're ever feeling unsure about your answer, you can always do this to check it. Now the next one I'm going to do is the one right below it. This n minus 4 is equal to 2. So once again, this equal sign is an immovable fence that should never move. You should be able to draw a mostly vertical line down all of your equal signs. Now, you next locate the variable. The variable is over here on the left side of the equal sign. So you're going to focus first on the left side of the equal sign and move anything that is on this left side of the equal sign over to the other. So what's the only operation that is being done on this variable? We are subtracting 4. So the opposite of subtraction is addition. So what I'm going to do is to get rid of this minus 4 is I'm going to add 4 to both sides of the equation. Because whatever you do to one side, you have to do the exact same thing to the other. Now on the left, -4 plus 4, opposites add up to 0. And then n plus 0 is just n. And again, leave the equal sign where it is, and then we're going to do the exact same thing on the other side. 2 plus 4 is going to give us 6. Now, because the only thing that's being multiplied by n is a hidden positive 1, and there's nothing being added or subtracted, that means n equals 6 is our final answer. So if you guys haven't yet, I want you guys to try the next two. So I want you guys to solve for the indicated variable for the next two, and go ahead and pause the video and resume when you are done working. Okay, so looking at the next one, x plus 5 is equal to 14. So let's locate our variable. The variable is here on the left side of the equal sign, so we're going to start with the left side. And the only thing that is being done to this x is that we are adding 5. So the opposite of addition is subtraction. So the opposite of adding a positive 5 is subtracting 5 from both sides. So then 5 minus 5 is 0. X plus 0 is just x. Leave the equal sign alone. And then on the right-hand side here, we're going to do the same thing. We're going to do 14 minus 5, which is equal to 9. And then if you want to mentally check your answer, x equals 9 does indeed satisfy the equation, so x equals 9 is your final answer. And then for this last one, we're going to locate the variable that we're trying to solve for, which is right there. And we're going to remember that we're not going to move the equal sign. The only thing that is on the left side that's being done to this t is we are subtracting 9. So the opposite of subtracting 9 is adding 9. So I'm going to add 9 to both sides of the equation, because remember, whatever you do to one side, you have to do to the other. So then on the left, -9 plus 9 is 0. And then t plus 0 is just t, so t is now by itself. And then on the right, 18 plus 9 is 27. So your final answer is t equals 27. So I want you guys to try each of these by yourself. Now, it doesn't matter what side of the equation the variable is on. The variable is not always going to be on the left side of the equation. It can also be on the right. You just need to start with locating the variable that you're trying to solve for and focus on that side of the equation and undoing any operations that are on the same side of the equation as your variable. So I want you guys to go ahead and pause the video, go through each of these and solve for the variable, and then resume when you are done working. All right, so for this next one, remember, don't move the equal sign. The variable is right here on the left side of the equal sign. So I'm going to focus on what the operations are on the left side. So on the left side, I have this -5. The opposite of subtraction is addition. So I'm going to add 5 to both sides of this equation. On the left, -5 plus 5 is 0, leaving you with x by itself. Equals, and then on the right, remember your rules for adding and subtracting negative numbers. So we have -11 plus 5, which is going to give us -6. So then for this next one down here, we have r plus 5 is equal to -3. So again, the variable's on the left side, so I'm going to focus on the operations that are here on the left. On the left, I have this plus 5 that's attached to this r, so the opposite of adding a positive 5 is subtracting 5. So I'm going to subtract 5 from both sides. On the left-hand side, 5 minus 5 is 0. R plus 0 is r. Equals, and then on the right, -3 plus -5 is -8. So r equals -8 is your final answer. Now for this next one, -9 equals a plus 6. The variable this time is on the right side of the equation. So you're going to focus on the same side as the variable that you're trying to solve for. On the right side of the equal sign with the variable, we are adding 6. So what I'm going to do is I'm going to undo this adding a positive 6 by subtracting 6 from both sides. Leave the equal sign where it is, and you can have and then on the other side, a plus 0 is a. And then on the left here, we have negative 9 minus 6, or negative 9 plus negative 6, which is negative 15. And yes, you can leave it like this. Or if you really don't like the way this is written, you can switch it around. A equals negative 15 is also perfectly fine. You can switch whatever's on the side of the equal sign, so you can switch it to be a equals negative 15 without any issues. Like addition and subtraction, the equal sign is commutative, so you could swap them. And then for this next one, this last one, the variable is here on the left side of the equal sign, so I'm going to focus on what's going on the left. So I have m minus negative 26 equals 32. So the first thing I notice is that I am subtracting a negative. Let's first simplify this, make our lives a little bit easier. So subtracting a negative, I'm going to turn into addition. So I'm going to turn this into m plus 26. So I just did a little bit of simplifying first. This is going to take more than one step to solve, which isn't a big deal. But after I did that little bit of simplifying, I noticed that I now have m plus 26 equals 32. So on the left here, with our variable, we are adding 26. The opposite of addition is subtraction. So I'm going to subtract 26 from both sides of the equation. 26 minus 26 is 0, leaving us with m by itself. And then on the right, 32 minus 26 is 6. So then m equals 6 is our final answer. And remember, if you want to check your answer, you can just plug 6 back into your variable in the original equation. Now that was how to solve one-step equations that have addition and subtraction. Now, the next thing we're going to do is solving one-step equations using multiplication or division. So what this involves is when there's multiplication or division that is on your variable, how to get rid of that multiplication and division to get the variable by itself. Because remember, the variable is considered by itself when the only thing that's being multiplied to it is a hidden positive 1. And just like with addition and subtraction, same thing here. Whatever you do to one side of an equation, you must do the exact same thing to the other. So if you're going to divide one side by a specific number, you need to divide the other side by that exact same number. Now, multiplication and division are opposites of each other. So if the equation involves multiplication, like there's multiplication that's attached to your variable, what you're going to do is you're going to undo it by dividing both sides by that coefficient. If the equation involves division, which will probably be written in fractional format, you're going to multiply both sides by the denominator because the opposite of division is multiplication. Now, if the equation involves multiplication by a fraction, such as a situation like 1/2 x, then what you're going to do is you're basically going to divide by the fraction. And you might remember from the video that we did on dividing fractions involves keep, change, flipping. It involves multiplying by the reciprocal. So what you're going to do is when you have multiplication with a fraction, you're going to multiply both sides by the reciprocal. This is the same as dividing by the fraction, but it just saves you some steps. So if your equation involves multiplication of a fraction, you're going to undo it by multiplying both sides of the reciprocal. Remember, any two reciprocals multiplying cancel out to become 1. So remember, when you multiply reciprocals by each other, reciprocals always multiply to 1. And in any of these three cases, what's going to happen is that they're going to cancel out and multiply to positive 1. Also, if you have a negative coefficient, like negative 3x, for example, where x is being multiplied by negative 3, the variable is considered by itself when the only thing that's being multiplied by it is a positive 1. So you want to make sure that any negatives are also getting canceled out. And remember, a negative divided by a negative is a positive. And same thing with a negative times a negative is also a positive. So that's how you turn negatives into positives. So we're going to solve the equation 5x equals 20. First of all, there is hidden multiplication between the 5 and the x. So the opposite of multiplication is division. So what I'm going to do is I'm going to undo this times 5 by dividing both sides by 5. Now what happens on the left-hand side here is that 5 divided by 5 is 1. Anything divided by itself is 1. And then 1 times x is just x. So that means that the variable is by itself, since anything times 1 is just itself. So 1 times x is just x, and x is now by itself. And then on the right, 20 divided by 5 is 4. So then x equals 4 is your final answer. Now for the one that's right below it, the 5 equals y over 2. Again, you're going to focus on the side of the equal sign that contains the variable. So since the variable is on the right side of the equal sign, I'm going to focus on the right side. You can read this y over 2 as y divided by 2, because remember, fractions are the same as division. So what is the opposite of division? The opposite of division is multiplication. So I'm going to undo this dividing by 2 by multiplying by 2. And then whatever you do to one side, you have to do the exact same thing to the other. So I'm also going to multiply the left-hand side by 2. And what happens here is 2 divided by 2 is 1. Multiplication and division by the same number cancel each other out. And then on the right side, we are left with y by itself now, because y times 1 is just y. And then on the left, 2 times 5 is 10, so y equals 10 is your final answer. And again, you can either leave it like this, or if you really don't like it, you can switch them. It doesn't matter. So I want you guys to try the rest of the equations that are on this slide. They're either going to involve multiplication or division to get the variable by itself. So I want you guys to pause the video, try out these other 4 equations, and then resume when you are done working to check your answer. All right, so for this next one, for 2x equals 6, remember there is hidden multiplication between the 2 and the x. So what I'm going to do is I'm going to undo this times 2 by dividing both sides by 2. So on the left-hand side, 2 divided by 2 is 1, and then 1 times x is just x. I'm going to have to move it over here, so I don't want to do whatever that was again. And then on the right, 6 divided by 2 is 3, so x equals 3 is your final answer. Then for the next one here on the top right, we have 6x is equal to 30. So remember, there is hidden multiplication between the 6 and the x. The opposite of multiplication is division. So I'm going to divide by 6, and then whatever you do to one side, you have to do to the other. On the left, 6 divided by 6 is 1. 1 times x is just x. Leave the equal sign where it is, and then on the right, 30 divided by 6 is 5. So x equals 5 is your final answer. Then for the next one, 1 equals a over 6. So I'm going to focus on the right side since that's where my variable is. I'm going to also read this a over 6 as a divided by 6. So what is the opposite of division? The opposite of division is multiplication. So I'm going to undo this dividing by 6 by multiplying by 6, and then whatever you do to one side, you need to do the exact same thing to the other. So then on the right, 6 divided by 6 is 1, leaving you with a by itself. And then on the left, 6 times 1 is 6, so a equals 6 is your final answer. And then for the last one, we can read this as m divided by 2 is equal to 5. So I'm going to focus on the same side as the variable. The variable's on the left, so I'm going to focus on what's on the left. So I'm going to undo this dividing by 2 by multiplying by 2. And then whatever you do to one side, you need to do to the other. So I'm going to multiply that 5 by 2 as well. So then on the left, 2 divided by 2 cancels out, gives you 1. 1 times m is just m. So m is now by itself. Equals 5 times 2 is 10. So m equals 10 is your final answer. So for each of these, remember that you want your variable to be positive in the end. So the only thing that you want being multiplied by your x is a hidden positive 1. So if there are any negatives that are attached to your variable, like I'm looking at these last two, you need to make sure that you are dividing by a negative number so that the negatives cancel out to become a positive. So I'm going to let you guys try these four by yourself. The hint that I will give you for this one over here, for this negative y equals negative 15, is what number is hidden between the negative and the y. There is a hidden 1 between the negative and the y. So you can think of this as negative 1 times y equals negative 15. Now, the variable is not by itself here because remember, we want a positive 1 being multiplied by our y. So you are going to have to do a little bit of work to solve this. So I want you guys to go ahead and pause the video and try these four and then resume when you are done working. All right, so for this first one, for this x divided by 4 is equal to 11. So I'm going to undo this dividing by 4 by multiplying both sides by 4 because whatever you do to one side, you need to do to the other. So then on the left, 4 divided by 4 is 1. 1 times x is just x equals, and then on the right, 11 times 4 is 44. For this next one on the below it, this negative 1 times y equals negative 15. Remember, the variable is only considered by itself when the only thing being multiplied by it is a positive 1. So I'm going to undo this times negative 1 by dividing both sides by negative 1. So negative 1 divided by negative 1 is positive 1 because anything divided by itself is 1. 1 times y is y, so y is now by itself, equals negative 15 divided by negative 1 is positive 15. So then that is your final answer. Then for the next one over here on the top right, I have 9 times x equals negative 72. So I'm going to undo this times 9 by dividing by 9. Whatever you do to one side, you need to do to the other. So then 9 divided by 9 is 1. 1 times x is just x. Equals negative 72 divided by 9 is negative 8, because remember, a negative divided by a positive is a negative. And then for the last one, the variable is on the right side of the equal sign this time, so we're going to focus on what's going on the right side of the equal sign. So what is going on here? What operation is actually done on your variable? This 46 is not being subtracted. Because there is hidden multiplication between this negative 46 and n, that means this negative 46 is being multiplied by n. So to undo multiplication, you use division. Now what are we going to divide both sides by? We are going to be dividing both sides by negative 46. So I'm going to divide both sides by negative 46. On the right-hand side, anything divided by itself is 1, and a negative divided by a negative is a positive. So negative 46 divided by itself is going to be positive 1. 1 times n is just n. And then on the left, positive 46 divided by negative 46 is negative 1. So n equals negative 1 is your final answer. Now, the big thing that we have not covered yet is what to do when your variable is being multiplied by a fraction. Remember, dividing a fraction involves keep, change, flip. So we're going to save ourselves some extra steps by just doing the keep, change, flip right off the bat. So when there is multiplication by a fraction, what you're going to do to get rid of it is multiply both sides by the reciprocal. So I have this 2/3 times n is equal to negative 6. So what I'm going to do is I'm going to take both sides, and I don't care how you indicate the multiplication, whether you do it with a parentheses or with a multiplication dot, whichever. And I'm going to multiply both sides by the reciprocal. So I'm just going to do the keep, change, flip right off the bat. So the reciprocal of 2 over 3 is 3 over 2. And remember, whatever you do to one side, you need to do to the other. So I'm going to multiply the other side by 3 over 2. So here's what happens. On the left-hand side, any number times its reciprocal is equal to 1. So, 3 over 3 is 1, 2 over 2 is 1, 1 times n is just n. And then the other side is going to involve multiplication by a fraction, which, remember, you can turn any whole number into a fraction by putting it over 1. And you can cross-reduce. So I'm just going to ignore the negative for a moment. 6 and 2 have a common factor of 2. So I'm going to divide both of those by 2. And then just multiply what's left over. So negative 3 times 3 is negative 9. Over 1, negative 9 over 1 is just negative 9. So your final answer is n is equal to negative 9. Now for this next one that's right below, and I'm also going to walk you through this next one, this is another very common way of writing multiplication by a fraction. So you can rewrite this 2w over 3 as 2/3 times w equals 8. So it's just another common way of writing multiplication by a fraction. Mathematically, you're going to solve it in the exact same way. So since the 2/3 is being multiplied by w, I'm going to divide by 2/3 by multiplying both sides by the reciprocal. So the reciprocal of 2/3 is 3/2. Whatever you do to one side, you need to do to the other. On the left, a number times its reciprocal is always equal to 1, so w is now by it. Sorry about that. So w is now by itself. That's not supposed to be there. So w is now by itself equals, and then I'm going to turn this 8 into a fraction by putting it over 1, and I'm just going to do some cross-reducing to make my life easier. So 8 and 2 have a common factor of 2, so I'm going to divide each of those by 2, and then multiply what's left over. So 4 times 3 is 12. 12 over 1 is just 12, so w equals 12 is your final answer. So I want you guys to try that for these next two. Remember, dividing by a fraction is the same as multiplying by its reciprocal. So I want you guys to solve for the variable each of the next two by multiplying both sides by its reciprocal. So go ahead and pause the video and resume when you are done working to check your answer. All right, so for this next one, because the 3/4 is being multiplied by x, I'm going to divide by 3/4 by essentially multiplying both sides by its reciprocal. So the reciprocal of 3/4 is 4/3. And then whatever you do to one side, you need to do the exact same thing to the other. So I'm also going to multiply the right side by 4/3. On the left, any number times its reciprocal is 1. So 1 times x is just x, and x is now by itself. And then on the right, I'm going to put this 12 over 1, and I'm going to do some cross-reducing to multiply these two fractions. So 12 and 3 have a common factor of 3. 3 divided by 3 is 1. 12 divided by 3 is 4. Then 4 times 4 is 16. The denominators are just 1, so 16 over 1 is just 16. So x equals 16 is now your final answer. And then we're going to do the same thing for this last one. This x is being multiplied by 6 over 7. So I'm going to undo that by multiplying both sides by its reciprocal. So the reciprocal of 6 over 7 is 7 over 6. And then whatever you do to one side, you need to do the exact same thing to the other. On the left, reciprocals always multiply to 1. 1 times x is just x. Equals, I'm going to ignore the negative for just a second, put this 12 over 1, and I'm going to cross-reduce. So 12 and 6 have a common factor of 6. So 6 divided by 6 is 1. 12 divided by 6 is 2, but it is technically negative. And then I'm going to multiply what's left over. So negative 2 times 7 is negative 14. Over 1 times 1 is 1. Negative 14 over 1 is just negative 14. So x equals negative 14 is your final answer. Now, I will make the disclaimer that most equations are going to take more than one step to solve. Not all, there's plenty of one-step equations out there. But what we're going to be doing in the next video is using the same idea of opposite operations canceling out to start to solve equations that are more complicated. So the equations that we're going to solve in the next video have two operations that are being done on that variable. That means you will need to do two steps to solve them because you have two different operations to undo. So these equations are going to get more complicated as we go, but for now, this first batch of homework just deals with one-step linear equations. So thank you all very much for watching, and I will see you guys in the next video.